The broadcast is now starting. All attendees are in listen-only mode.
Right. Good afternoon, good morning. Hello, everybody. Welcome to today's webinar. My name's Dave Thompson. I'm a supporter for Pandoras Box, and I have my colleague Daniel Kaminski. He is a Pandoras Box expert and a beta tester, and he will be joining us today to assist me
Hello, everybody.
with this topic. Hi, Daniel. Welcome. Thank you. Right, so let's kick off. We're going to talk about Pandoras Box and multi-channel audio. So what we're going to cover will be broken down as follows. So a brief overview of audio, a little bit about digital audio, audio formats, embedded audio versus separate audio, why ASIO and ASIO Tracks. We'll talk a bit about clocks and Soundcards, and we will speak a bit about Dante as well. If you feel like asking questions, you're welcome to post questions, and either myself or Daniel will answer them. Okay, but let's dive in. Pardon me. So, what is audio? What is sound? Sound can be broken down as the movement of molecules in the air, which will then transfer this information to our ears. It can also be represented mathematically and can be described as a wave. Most humans, well, pretty much everybody can hear from about 20 hertz up to 22 kilohertz. Obviously, you can feel lower frequencies. And as you age, obviously your response to those higher frequencies slowly diminish. Audio can be defined as a wavelength, and it also has amplitude. So the higher your wave is, the louder the sound is, and the shorter the wavelength is, obviously the higher the frequency becomes. So because I said it can be described as a wave, we can also represent it mathematically. So if you look on my screen, you can see, three representations of a wave. And if you look at the left of the image, you can see a very low sample rate file being sampled. And then as we move to the center and then we move to the right, it has a higher sampling rate. So the sampling of the audio allows us to have a look at those waveforms, and then the bit depth also allows us to get more points to measure those values. So the higher your sample rate is and the more bit depth you have, the more accurately we are able to reconstruct that waveform once it's been passed through the digital interface. Also, once we've captured it, processed it, and then played it back out again, the more information we are able to analyze the waveform with, the more accurately we can reproduce it on the other side. So audio can essentially be transferred in a couple of ways. We can we can capture audio in a compressed manner, or we can capture audio in an uncompressed manner. So here on this slide, you can see just basically a very simple representation of compressed audio versus wave audio. I'll talk a bit more about waves in a moment, but essentially, so compressed audio is MP3, or a wave file is an uncompressed source. So it's trying to be as accurate and as representative of the original source file. So for example, here you can see just the breakdown of, on the left-hand side is the representation of compressed audio versus uncompressed audio. And this is just an illustration of how audio is handled inside of our systems. Okay, so if we compare an uncompressed wave file, which is 11 times larger than a compressed MP3, we can then see it being represented here in this slide. You can see that for 1 second of uncompressed full HD video, 1 second of uncompressed audio, so a wave file playing, is less than 1% of the total data stream that would be moving through your system at that point in time. So audio is very when you compare audio to video, it's really a small amount of information, and this is why you're able to send audio down an HDMI cable, for example, and you can move your 5 or 6 channels down HDMI quite easily without causing a lot of problems. So how do we correlate this with Pandora's Box? So Pandora's Box, we are able to support quite a lot of audio formats. Obviously, we can have PCM wave. PCM stands for pulse code modulation, so that's just the method that it uses to analyze the incoming audio. There's MP3s and M2A, which is MPEG-2 audio. The sample rates, again, so 44.1 is just a CD quality or CD's sample rate. 48 kilohertz is used for DVD audio and broadcast, and then obviously you can move up to 96 kilohertz, which is the sampling rate that a lot of the digital consoles are working on. Then obviously your bit depth, which is handled in Pandora's Box, you can either have 16 or 24 bit. 16 bit, if I remember off the top of my head, it gives you 65,000 odd sampling points that you can have within a sample. And if you move to 24-bit depth, it's already moving over to 1.6 million points roughly. So you can get really high quality audio moving through in the digital environment. So then how do we handle audio inside of Pandora's Box? We can have embedded audio, and if you have a project with a video file playing on a player or on a server, and the video file has embedded audio, that means that on that particular client, the audio in that file and the video will be played out together on that local machine. So what that also means that the audio will be routed and output through the default Windows audio device on that particular machine. And it uses a direct show to sync the audio and the video together. So they are played out together as one thing. Another point to note is that in Pandora's Box, MP3 audio can only be played out on a video layer, and it uses the direct show. Again here, as I mentioned, just to remind you of the point, so audio on video layers is handled through direct show and is routed through Windows audio. So on that machine, that local client playing that audio on that video layer, that audio and video will be started and it will be in sync on that machine. Right, if you want to play mixed audio, so multiple channels in one audio file, that also is supported on video layers, and it is played back in sync on that machine. Okay. Yeah, are there any questions at this stage? Doesn't look like it. Okay, cool. So let's move on. Okay, thank you. So, right, the next question is, okay, I've done, I've got a simple project, but now what happens if I've got more systems in a machine? I've got multiple channels of audio that need to be played back. And my project's a lot more complicated. So how do we deal with that? How do we reliably play back audio in a show environment or in a project? And we do this in Pandora's Box by using ASIO audio. ASIO stands for Audio Stream Input Output. It was developed by Steinberg, and the idea is to bypass the Windows operating system and speak directly to the audio card. So the application speaks to the audio card. It minimizes the amount of latency. Latency is just delay, pardon me, that you would pick up in a computer. So if everything was being routed through the Windows system, operating system, you would then pick up a bit of delay. So it bypasses it and helps to just improve the timings on everything. So obviously, for this to work properly, you need special hardware. So you need ASIO capable devices, and you need to have proper drivers. yeah, so the ASIO is always active. So even when no audio is being played back, those tracks are active and are always outputting audio. But they will, if there's nothing on there, they will just essentially be putting out no audio. Okay, so ASIO Tracks with Pandoras Box. Right, so they are special stereo audio tracks. They are synced to each other and to the video. You can play back up to 64 channels of audio. You can even do a bit more, depending, again, of course, on the ASIO card itself. The levels are in real decibels, and they are from minus 96 dBs being muted to plus 6 decibels, which is obviously 2 times unity gain. So you can obviously, if you need to, you can obviously increase the output that is coming from a particular output, or increase the level coming out of an output, sorry. So at unity gain, so at 0 decibels, where the audio tracks are at their default, it will play back the audio file at its the default. It'll play back the audio at the level of what it is saved at in that particular file. Right, so we also recommend having a master clock set up as a source for syncing. That obviously improves overall syncing. I think Daniel can also jump in here if he has any more points to add to it. But so we recommend having a master clock running, and we use an audio clock because it is a lot more accurate having 48,000 or 96,000 samples per second than having only 60 samples a second of a video output. So if you're using a video clock for an output, you're not really going to get as accurate a sync if you compare it to 48,000 possible timings in a second. So that's why we set up a master clock, and that audio clock becomes the master for all the machines, essentially. Right, so you can also, in Pandoras Box, you can set up the sound card to be played back from your local machine or your manager. So if you have a manager, you can connect your sound card to your manager, or you can use a sound card on a client. So that gives you the flexibility to exactly determine how you want to set up your audio in a project. So we give you that flexibility, and there can only ever be one master clock in the system. So you can have, so that's all the timing goes back to one point. Okay. Also, for example, if you have SMPTE audio, so if you're using timecode coming in and you have a master clock, you can't use both of them. Obviously, then you need to switch to the SMPTE timecode coming in as being your clock. Yeah. So right, we're going to move on now to our next slide, which is ASIO audio card settings. What I'm going to do is just, sorry, I just want to connect through to the Pandoras Box. And let's just see here. Okay, so here's our Pandoras Box project. We've got, we can see our local machine. There's our manager represented as a local. Our server is site 2. And we've set up a couple of audio tracks on it, and we've got our sequence represented there, right? So now in my project, I need to tell the manager that the sound card that we're going to use is on server 2, on our site 2. So on our, well, sorry, it's labeled here as server 1. So we're going to go to the ASIO audio tab inside of the configuration tab. Thank you. And we're going to select server 1. And then we're going to select our sound card. So there we go. We select the ASIO Hammerfall, and then once that is selected, and we've set our sample rate, we can then go to the top and say use the audio clock as master. So when you click on it, it will say ask to run as master, and then once it's locked, it'll confirm that it's running as master. Then if we scroll down a little bit, then we can see there we can set a master value, master volume for our card. By default, it's normally at -9 decibels. You obviously can increase or decrease it as per your requirements. There we go. and if you reset it, it will go back to -9. So then there's also the show channel tab. We can talk a little bit about this. This literally just shows you a breakdown of your selected cards. So I can see here my output channels. I've got 16 channels of audio out, and I have 16 channels of audio input. It's literally just a representation. You can't actually access those channels from this drop down. So, okay, so that's the first thing. So we set up our sound card. We did set our sample rate, and now we want to start adding some content into our project. So obviously we drag our content in from our assets tab. We've already got the setup in our project here, and if I select a file, you can also see, it gives me the duration. Obviously I have my file name. I've got a little icon to show me that it's an audio file, and I have the sample rate for that audio file. Again, what is very important is make sure the sample rate that is shown in your project is what is being played back on your audio card, because if they do not match, you're going to be having files played back at either too fast or too slow, because the clock rates don't match. Right, thank you. So let's talk a little bit about the device tree. So what are we seeing in the device tree? In the new 6.4 version, we can see all of our obviously our devices in our server, and we also have the tracks now showing a mute and unmute icon. So the same as when a layer is being rendered or not rendered, you can also show here that my audio track is set to playback audio and is not muted. Okay, that again you can set in the inspector as well, so you can mute the audio from the inspector, and you can also do it from device viewer. So if you click on your device viewer, and as you mute and unmute, you can actually see that it updates in all three positions. So they're all linked to each other, and each they have what's the word, cross functionality. So if you click one, you click all of them. Okay, so while we're talking about, actually let's just go back to the device viewer quickly. We can just show the functionality in the device. Obviously you can set the volume. It'll show in the media, it'll show the track name if you have a file dragged in there. There we go. You can set an in point and an out point in that particular file. And again, on the end, you can set up your panning, so left and right. Obviously if it's in the center, it will then output to both channels, but we'll come to that a bit more later. Again, you can play, pause, and set loop commands. Okay, so all right, so now that's the functionality of the device viewer. We can have a look at our sequence. So now in Pandora's Box, once you've dragged your video with embedded audio, or whether you drag in an audio file into your project, Pandora's Box will quickly go and analyze that file, and it will create some waveform information. It'll create waveform data, and that is then shown in your track layer as a physical representation of your audio files. You can also, you'll see as we change that, that you can see the waveforms being represented there. So as you change your sorry, if you for example, I have to gather my thoughts. If you are updating, if you need to chop a video, for example, and you're trying to cut something to a beat for a customer, you can then use your waveform as a physical representation of what's happening inside of your audio file. Yeah, okay. Then you can also change the way that your sound file is represented. So you can set it to a standard waveform or a rectified waveform. The standard waveform obviously just has your positive and negative values set to obviously your center representation, or they're justified to the center point. If they are rectified, then everything is just sort of, if you were to take the whole sound file and drop it onto a table, all of those points would set up to a 0 position. I think that's probably the easiest way for me to try and explain that. So that's what's happening in the rectified waveform. Then we have our device viewer, which then allows us to see what is happening on our particular clients. So you can use your drop down and you can look at different different clients in a project, and you can see, okay, here I am, I'm looking at server 1, and I want to see what is being played back on that particular server. So you can see here, there's my wave file playing back. It is showing me a couple of things that I can quite easily and quickly see there, and that is I can see my sorry, 1 second. I can see my site. I can see my the duration of my resource, so I can see how long my sound file is. I can see the name of the file, and I can also see the volume. So if I have any keys programmed in there, as I play back, you will see those values changing. Also, what you'll also notice is I have 2 little meters showing my audio. So you see, as the now pointer is, or as the sequence is playing, the audio is fading out, that's coming out of the output, but my meters are still moving as they should be. Okay, that's maybe a bad part of the file, but you'll see now, there we go. So the audio is playing back. What's being represented in your meters is pre-fade listen, so it's a PFL level. And that is the same as an audio console. So if you had your headphones on, you could listen to what is coming from a particular channel without it going out through the PA system. The same thing applies here in Pandoras Box. You can see that represented in your device viewer. Again,
we have one question here.
Yes.
That's a question if we can see the waveform bigger. Is it possible to assign the waveform window in the next version? Right now, we cannot see the waveform bigger. This is the only size we can see the waveform. We can zoom in, but we cannot see it bigger. We cannot make it higher. I hope this answers the question.
Cool. Thank you, Daniel. Thanks for that question. Yeah, so now let me just catch up to my thought again. Yes, okay, so as you can see in our sequence, we've got some keys. We've got some keys stored in there. So the same as a video layer, you can store volume keys inside of your project. You can obviously change your curve type, and you can access that inside of your inspector as well. So you can change it to have a nice fade. You can change to Bezier corner, etc. So the same as you do in a video channel, you have the same functionality with the audio keys as well. Okay, so yeah, look at that. There we go. So, right, we can set that up. Now, if we look in the next part of our project, here we can see, so here's some multi-track audio being played back, and we've got our, is that 1, 2, 3, 4, 5? We've got our 5 layers being played back. We've got separated audio, so we can see bass, drums, guitar, and lead electric guitar. You can see all of the channels are coming out. I know that I'm getting audio out of all of my channels. So another nice thing about having the audio being shown directly in the device viewer is you can just instantly, by looking at your GUI, you can see, okay, my audio is playing back, everything's coming out from me as it should be, but maybe the audio engineer is fast asleep and hasn't opened the channels. So if you're not hearing audio coming out, you know that your files are playing back as they should be. So just check the audio guide to make sure that he hasn't muted any of your channels. Right, so we've got our multi-track playing, but if we were, for example, we wanted to route those audio tracks to different outputs, we could then So for example, we have track 1, track 2, track 3, track 4, etc., etc. And we can then go into each individual track, and we can assign where we want to route those out of our sound card. So if you cast your mind back when we were setting up our channels, or when we were setting up our audio card, we could then go and have a look at our audio channels. The channels that are represented there, so 1 to 16, corresponds to the physical outputs on your audio card. And when you want to route your audio tracks or your audio layers to different outputs, you would then do that in the track inspector in Pandoras Box. So we want to send, what are we on? So we're, for example, on our guitar 1, and we want to send that out of, let's send it out of channel 1 and 2. So we can assign channel 1 and channel 2, and then that will automatically be routed on the sound card itself, and it will come out of the corresponding channels. Obviously that is stereo, so you would need to assign channel 1 to left and channel 2 to right. If you wanted to mute a particular output, you could just assign 0 into that left or right for that particular channel. And also it's a good point to note that you can't have the same output routed to left and right. So I can set up 3 in the left channel, but I can't set up 3 in the right channel. So it needs to be a unique output. Then if you wanted to send only one channel out of a particular card, you can then also, out of a particular output, my apologies, you could also then use the panning to shift everything out of channel 1 for track 3, for example. So you could then go into your device viewer and then do a pan and set up your output precisely as you would like to. Yeah. Are there any questions about that? Was I too fast? Questions?
No question at this point.
No question. Okay. All right. Thank you, Daniel. So I think we can now jump into talking about some audio cards. Daniel, do we need to cover anything else in Pandoras Box at the moment?
Yes, we do. Let me start my video. We also have the possibility to add delay to either audio tracks. So down here, we can add up to 3 seconds delay in our system. The first thing is if we have an audio that comes in and for some reason is not in sync with the other audios or something else, we can add a delay here. So every time we use the audio, now we have 100 milliseconds of delay on that audio file. So, and it will just play out 100 milliseconds later. And this goes up to 1 second, so 1,000 milliseconds. If we enter try to enter 3 seconds, it will go back to 1,000, so 1 second. There's another place where we can add delay, and that is the track itself. So for some reason, let's say our analog output is slower than our ADAT outputs. Then we can say, okay, our analog outputs 1 and 2. And on this track, we need a constant delay of, let's say, 60 milliseconds. So everything that's on this track now is delayed by 60 milliseconds. And we can also add delay to a particular container. So let's say only this container at this point in time needs 300 milliseconds of delay. I don't know why, but there might be the reason for that one particular container needs to be delayed. So, and all these delay add up on. So if I have the file here, it has already let's say 500 milliseconds of delay, and my container has 300 milliseconds, so it will be delayed a total by 800 milliseconds. So all these delays stack up. So if you ever run the problem and add delay somewhere, make sure you add it in the right place. If you want it on the whole track, if you only want it on the container, or if you want it on the file, and every time you use the file, there's a delay. So that's something pretty cool and maybe important to think of.
Nice. Thank you, Daniel.
Okay, back to you.
Yeah, so I'm now going to take over the presenting. Okay, so right, so let's talk a little bit about Soundcards. So we ship our Soundcards with, we ship our hardware with RME Soundcards in them. Because we obviously try and find the best hardware wherever possible that goes into our machines. So that's why we ship RME. They're brilliant cards. They have excellent drivers. We also recommend Dante, and we also have some customers that would sometimes use ASIO for all, which is okay. You can use it for pre-programming, but not for showing environments, because it is not a physical card. So it is not a hardware card. So it doesn't have its own clock. So it's ASIO for all just generates its own thing, and it's okay for pre-programming. I don't use it in a show environment. Ultimately, I think the best thing that what defines a good audio card is having one that has a stable clock and has a brilliant driver. So a reliable driver is critical. Pandoras Box also connects with Dante. We recommend Dante, so you can use Dante PCIe and USB 3 sound cards. They from Focusrite, Yamaha, and RME. You can also use Dante Virtual Sound Card. Excuse me, but again, there's no secondary. It's no secondary network output. So if you have a network failover, then obviously you could have some issues. And if you are going to use Dante Virtual Sound Card, please make sure that you assign it to go out of its own network card or on its own adapter and over its own network. So wherever possible, separate your audio network from your Pandoras Box network. Yeah. Any questions about Dante? No. Okay, cool. All right, let's move on. So in Pandoras Box, we can also use audio inputs inside of Pandoras Box. This must be done on the machine that has the outputs attached to it. So if you're going to capture audio somewhere, it needs to be captured on the machine where it's going to be outputted. Obviously, because Pandoras Box operates over a network, you can't now then go and stream that audio over the same network. That's not how it's supposed to be done. If you want to capture audio, for example, you could put audio in. You could get SDI audio injectors and then receive SDI in, and then you can go and grab the audio streams from the SDI. So now let's go back to Pandoras Box and let's dive in there so we can have a look. See, okay, so now we're going to input some audio into Pandoras Box. So we're going to input audio. So here I've got my inputs dragged in from my server, from my live inputs folder in my assets tree. I have so there we go. There's my live inputs. There's my SDI card coming in, and we're going to capture you can also grab it in directly from the card itself. And we've dragged them into our project, and we can see the different channels. So they're all represented there. Tells me the sampling rate in Inspector, which obviously is important, and that sample rate's been set by the card itself. You can obviously drag that and then apply it to a track layer, and then use that resource inside of your project. There we go. There's our input. Obviously, it's not going to generate a waveform because it's not a file itself. It's a stream, so you can't represent a audio stream in that situation. Then if you want to use if you want to use an embedded stream in an SDI feed, then you can go and drag your channels for your audio onto a. You can go. Sorry, let me rephrase that. You can grab your audio channel from that SDR stream and you can apply it to a track layer. But in order to activate the processing for that, you need to go and take the SDI itself and then put the SDI input onto a video layer. It does not need to be shown on screen, so the SDI can be just on the track on your sequence. But it doesn't need to be shown on an output anyway, so you can actually move it off of your outputs. But if you want to use the audio input, the video needs to be activated and needs to be processed. Okay.
There's a couple of questions.
Okay.
Here.
Yep.
Number one questions. Version 6.4 supports NDI audio inputs. The answer will be at this point not, as I'm not sure is the answer. I'm not sure if the NDI capture driver supports audio as well. I would have to check on that. But there's no native NDI support yet. That is planned for a later version of Pandoras Box. And with NDI capture support, we'll also have NDI audio capture support when that comes. And then there's a second question. Audio from embedded from HDMI are managed in Pandoras Box. Let's check. We have an HDMI card here. No, there's no audio support for HDMI. The problem with that is that the audio on HDMI can be very many different things, and it's so it can't be extracted. So there's no capture of HDMI at this point. Also, can I put the HDMI stream on a graphics layer in order? Yes, you can. You don't need to have to use a video layer. You can put it on a graphics layer. Good question, Janina.
Cool. Okay. Right. So that should cover inputs. Okay. So let's move on. I'm just going to go back into the PowerPoint again. 1 second, please. Okay. So that's kind of sums up where we are at the moment in our project, or this kind of covers audio in Pandoras Box. Let's go on to some tips and tricks which will help you as an operator. There we go. So one thing that you may have heard in Pandoras Box, if you have well, you may end up with a situation where you might be hearing the beginning of your audio at the end of a video file, or at the end of a track. So your video plays, comes to the end, and then you hear a little blip, or you hear just the first few samples of your audio being played right at the end of the track. And what is actually happening is because video is obviously 30 or 60 frames per second, you can have obviously more samples sitting inside of your audio. So your video is at 60 samples a second, but your audio track is at 44.1 or 48 kilohertz, for example. This does mean that you can have, for this example, it's at 48 kilohertz, and that would give us 800 samples in a 60-second video frame. As you can see here, our audio track is ending 200 samples past the end of our video. But because our looping is on, it then goes and plays 600 samples from the beginning of our audio file. So the way to make sure that this doesn't happen is to switch off your loop on your video and audio container for that particular file. So this will stop it, the render engine from going back and looping the audio up and to make sure it is the same length as the video file. Then if we move on, so in summing up, pretty much you can use multi-channel to your advantage. What I used to do when I was an operator is I would ask the audio guy or the content creator to give us the audio files in 3 separate components. So I'd always ask for a music bed, a voiceover channel, and then an effects channel. This way, your audio engineer can mix the audio for the venue that you're in, and not have an audio engineer sitting behind, in a treated room mixing on a pair of monitors. It's better to have three separate tracks and let the audio engineer mix for the venue, because then he'll be your best buddy. Again, using multiple outputs, you can also set up Pandora's Box to play your SMPTE audio files out of your sound card, so that other devices can sync to you. Then there is a website, so LTC. It's a website where you can go and generate time codes specific to your needs. You are more than welcome to make a donation to the guy, because he's put up quite a cool service. So there's a little tip and a trick for you. And yeah, if you have any more questions, we'll be around here for a couple of minutes. Thank you for joining us today. I've put up our support email address. If you have any more questions, you're welcome to drop us a mail, and we'll gladly help you out. And yeah, Daniel, any more questions come in?
No, not so far.
Not so far.
Thank you
Okay.
very much, everybody.
Yeah, thank you, Daniel. Thanks for joining me. Thanks for joining us today, guys. Keep following our channels for updates on further webinars. And yeah, we'll be around for a couple of minutes in case you have any more questions. Thank you.